So in this video, we're going to talk about the last two of our 6 quadric surfaces. So we've already discussed ellipsoid, elliptical paraboloid, elliptical cone, and a hyperboloid of 1 sheet. In this video, we're going to talk about first the hyperboloid of 2 sheets, and then lastly, a hyperbolic paraboloid. So just to refresh, a hyperboloid of 1 sheet we had a standard form for that, which was x squared over a squared plus y squared over b squared minus some z over c squared. So the main thing you want to notice is the hyperboloid of 1 sheet had 1 negative. The hyperboloid of 2 sheets, negative x squared over a squared minus y squared over b squared plus z squared over c squared is equal to 1. So a hyperboloid of 2 sheets has 2 negatives and 1 positive, equal to 1. All 3 terms, x, y, and z, are squared. And the positive term, the one that's positive, lets us know the axis that we're going to be orbiting around. So in this case, we're going to have, or we will let z be the axis. And if we think about our traces, what shapes we get. So letting x equal a number, y equaling a number, and z equaling a number. If I let x equal a number, this becomes a constant. I have a hyperbola. If I let y equal a number, again, that becomes a constant, and I'm left with another hyperbola. And then lastly, if I let z be a number, I've got 2 negatives, so these are both the same sign. That's actually an ellipse. So we have 2 hyperbolas and an ellipse again, which were the same traces with our hyperboloid of 1 sheet. But this one looks a little different. We actually end up with a graph. We would travel up and down some c value. We'd have a positive c and a negative c. And then we have this hyperbolic shape, up and down, and rotating around. That's going to be both of those hyperbolas, creating this bowl shape. And we end up with these 2 bowls that have an ellipse or a circle as their opening. All right, so that's what a hyperboloid of 2 sheets looks like. Let me pull in the textbook picture with some more details for you. So here we have our hyperboloid of 2 sheets. It's written a little bit differently. They put the z in front, so we have a positive 1 term and 2 negative terms. It really doesn't matter which one's positive and negative. It's just that would determine which axis we are orbiting around, in a sense. So you can see we've got an elliptical trace and then a red and also a blue hyperbola, so 2 hyperbolic traces to create this space. I didn't fit on the screen well, but give yourself a minute, examine that. The main thing that, the only vertex or point on the graph we were noting is that we have this vertex at the C value. All right, so let's talk about our last quadric surface. So here we're going to see a hyperbolic paraboloid, which is a saddle shape. The hyperbolic paraboloid formula, y squared over b squared minus x squared over a squared equals z over c. So you'll notice here we do not have all 3 of our variables squared. right? We have one that is not squared. So that gives us a paraboloid, and this minus lets us know it's in the hyperbolic shape. So I'm just going to refresh you from the previous video. We talked about an elliptical paraboloid. So the elliptical paraboloid formula was x squared over a squared plus y squared over b squared equals z over c. You'll notice they're very similar. They're both paraboloids, but elliptical has a plus in between those two terms. Hyperbolic has a minus in between those two terms. Again, it could be x squared minus y squared. That would just change the shape. We set it up this way in our standard form because it's kind of the way we like to draw it and visualize it. In our hyperbolic paraboloid example, we do specify that c has to be a positive number, and that's mostly so that we don't divide and switch these two terms. That would change the shape of our graph, right? It would put them in the reverse situation. So let's look at what this graph looks like in my R3. What are my traces? So what happens if I let x equal a number? If I let x equal a number or y equal a number, x equal a number right here cancels that out. I have a parabola. Y equals a number, cancel that out. Again, I have a parabola. So both of these are a parabola. And if I let z equal a number, z equaling a number, we've got the difference here, that is a hyperbola. So what does this graph look like? We have two parabolas and then a hyperbola. It's kind of hard to draw. I'm probably going to destroy this picture, but we have a parabola in the YZ plane in this situation. So parabola in YZ. We also have a parabola in XZ. Parabola in XZ is in perspective here, like that. And then we have a hyperbola in XY. So we end up with this hyperbolic shape. I'm going to kind of draw it up a little bit. Hyperbolic shape on both of these. All right, and so what that ends up giving us is, as I try to sketch this, we've got this guy here. This is going over and then down the back. I'll kind of run through like that, and then we're going to again go over, and as we go behind, kind of comes down like that. So we have this saddle shape. That is a hyperbolic paraboloid. I'll pull in the picture, which is probably much prettier. So here we have this, our hyperbolic paraboloid. So it's this beautiful saddle shape. I think I didn't do too bad figuring it out, but you can see we've got the red hyperbola and then this blue and green parabolas. All right, so those are our 6 different quadric surfaces across the course of 3 videos. I'm going to do an example or two using these quadric surfaces, or considering what you might see on your homework.